underway last night and heading towards the visitor centre for the radio telescope is Jo again.
Good morning.
And we are right here.
And then
for people's own self-edification and their own professional development.
Occasionally, in my spare time really, I leave these instruments behind and I use a small instrument like this.
here we can see one of the key texts or works in the history of science. Copernicus is the revolution. That's good. That's what we're looking for. A little bit more while in.
Where are you from then?
I am from Bundaberg.
Bundaberg?
Bundaberg in Queensland.
Cool. And where are you from?
I'm from
Jane?
Montana in the eastern suburbs of Melbourne.
Yeah, it's excellent. It's really nice. I like the Aboriginal points of it because that really made a lot of sense to me as far as.
Wonderful dinner. Spoiling us rotten here. Spoiling us rotten with good science, good thinking, and big questions.
Enjoyed it very much. The first bit on the Aboriginal side of things was just excellent.
Ready? Set.
This activity is about classification and ranging the task from unstructured to extremely structured.
By the way,
so you can tell.
Will I get my screen running?
And so it's kind of nebulous in the sense that it's kind of gassy, but it has nothing to do with planets. And the reason it's called a planetary nebula is because ancient or 19th century astronomers thought that they
I'm biased. I think it's one of the best things you could ever do. Some of my most rewarding moments when I was teaching was star nights with kids.
Star we see tonight is
There we are.
This is a new experience for me.
Hello, I believe in the man in the moon.
Yes.
Okay, that's a pretty good memory.
No, I can't remember it. I've heard of it.
Oh,
Right, what will happen? Sorry?
No, that's
and you point it up and it gives you a reading. So
Yep,
we're going
so you
to
press identify.
identify it. So I'm pressing the identify button.
And it says Saturn!
Wow.
It's an impressive, it's one of the best looking starbirth regions around. It's a huge starbirth. With our telescope up at Coonabarabran called MOPRA, we've got a spectrometer built on that, and that's looking at millimetre wavelengths where you get all the molecular lines from molecules.
I just turned into the road into the dish, and lo and behold, on the radio is the song "The Real Thing."
Day 2. Today we get to see a bit more of the radio telescope. Last night we had a really good outdoor astronomy night. Jo and I were talking heaps about science curriculum, teaching.
Okay, this is where I'm going. Right. All right.
Okay. That's where you're stopping up each. Separate and join that together. Okay. So what do I want?
So it's a variation of a pinhole camera with a variable size box. This device at the back end moves, so we have an 8mm line, and we get an image of the sun to exactly fill the 8mm gap.
Complex. We'll have some more opportunity to get some other photos. Opened in 1961, operated continuously since then, although it's had several major upgrades. All that you can see above the red track there, what we call the azimuth track, is 1,000 tonnes of metal and electronics. A lot of it was built in Germany. As you see inside, it looks a bit like the interior of a battleship, which is good because it was so well over-engineered that it's allowed us to put all this additional weight and material on it that we'll explain. Vance Wallace designed the parabolic support structure. Because the dish is so heavy, it's about 300 tonnes, when you point it to different parts it will distort. But the beauty is that it distorts in a known manner, and so it's designed so that the focus cavity where the radio signals have to go are always in the biggest time is the 100 metre of Effensburg in Germany. So we've got their funding providing point to about 32 degrees above the horizon. We can't point it to the horizon. So we basically can observe in a sort of anything up 32 degrees.
Amy, what do you like most about this telescope?
It's big and you can get hair eyes on it, and it's 64 metres, and apparently it can detect flashes from cameras. That's
Wow.
That's pretty cool.
You want to start? Okay. You're going to come up now?
Come on.
So we'll have about 35.
35 plus us.
Well, no, that's including.
Oh, okay.
So you'll be driving up on this.
Yes.
It's a parabola, giant parabola. Awesome.
It was worth it. Just tell you that.
Nice knowing you.
Oh, she's got a Joey. Yeah. Oh, didn't notice a Joey. Wow.
I know you're crazy.
Well, we've got to get hang on. It's structurally separate. You'll see the next level down, the gap between the center column and the rest of the structure. These things here are the final limit switches, the hardware limit switches, if all the software limits stop working. And they've got a bit of perspex above them to stop birds landing on them. Very high-tech solution.
So we built these RFI radio frequency interference shielded racks, and in these racks you generally find an awful lot of computers. So do you know what the parameters are of this one?
The dual processor quad core Xeon, each has 8 or 16 bits of RAM.
Let's process it. So in our Minnie and I observed for about 10 hours. How many hours? 10 hours?
About 15.
We stored 3 terabytes of data coming on this telescope.
3 terabytes.
3 terabytes. In here you just see a bit more of this sort of equipment. We don't have to use a supercomputer cluster for our processing.
You'll notice also that the display here, the bottom right, is the wind. And you can see how quickly the wind can change.
Yeah.
Which is a bit of a...
Now, our biggest problem with things like this PDP-11 there is you can't go down the shop and buy spares anymore. So there's a few spares lying around, and when that really dies, then people will probably move to a Linux-based system or something like frequency on a different receiver. So the next display here is telling you what frequencies you're observing at. So if you remember the big box at the top, the focus cap bit, what's inside that is this. This is a video camera pointing in that building. It's a big 2-story building, how exciting. And this thing here is a receiver. So this is basically the thing that actually collects those radio waves. The sound you can hear is actually cooling it down to a very, very cold temperature.
2007. Correct. So, to challenge the kit, it's rotation.
And is that because the cross is the heavier side, so the heavy side sort of...
Actually, it's quite a complicated set of reasons.
Was it faster before and it slowed down? Or?
Yep, because it was closer before. So you have the conservation of angular momentum coming into the thing. But the conservation of angular momentum in terms of the Earth-Moon system is not very easy for high school kids to understand. But we can demonstrate it. So for example, and this is where we can go to geology, 400 million years ago. There's the crescent.
In here, it would be like reading that eye chart at a distance of 200 kilometres away, which I certainly know my eyes can't do. That we're limited. We have all that we have is 255 megabit per second links across batch straight.
So they also make huge simplifying assumptions. I was actually at one meeting where someone assumed that the value for pi equals 10 because it made all the maths a lot simpler.
Okay.
Rotate around, you can simulate the time. Go down to Mars, I can zoom in on Mars, and so you could then, for instance, go and sit on Voyager 2, and you could do the tour of the planets there.
Click on Saturn, just like so, and in the infrared camera, you could see it moving. So here's the nucleus of the galaxy. I can see the bar, and I can see spiral arms. So do I want to see them? Yeah, let's do a quick and dirty again. The camera is actually not bad. I mean, the image that you see here has very few artifacts on it. A proper scientific camera costing many tens of thousands of dollars. So you get the idea.
So my predictions, it's always good to give a prediction at the end. I predict that
Science is really cool, and it's cool because you can solve the problems of the universe, and you don't have to study pulsars to do it.
You don't have to study pulsars.
Which is a pulsar.
Science is really cool because you're basically on the cusp of technology. You're seeing things for the first time that no one's ever seen. And the best thing is that it's not hard to do at all. It's something that you can do if you want to do it.
Wow, that sounds cool.
I think so.
Are pulsars cool?
Pulsars gravitational.